these. Oh yeah. Right. So what's the first thing you need to do in this assignment?
Introduction
I know, but even before that,
is
get your numbers. Very first thing. So what I'll do is I'll grab some numbers. So I'll sign in. Okay, I'll go to Maths Part 1. And I'll go to, not that one, sorry, this one here. And I'll type in, uh-oh. Okay, that's weird. Does this happen to anyone else?
no.
This is literally only happening to me right now. Ah.
I can give you my number.
No. That's, thank you. That's very kind of you. I can get my own numbers.
I think negative 10 is a good number.
What the heck's happening?
I'm giving you the right number.
Maybe I need to sign in as actually a real person. Okay, let's try this again. Data. Okay, it might just be my laptop. Does anyone else have this page open? And is the box there?
Yeah.
It is, so it's literally my laptop right now. So can you type in this student number? DB,
So, DB,
yeah, 15,
capital,
yes,
15,
0, 0, 0, 0. And then you can tell me the numbers.
5,
Whoa, slow down there.
Negative 10.
Hang on, I need to write them down somewhere. Negative 10. Come on.
negative 3,
Negative 3.
negative 1,
Minus 1.
negative 1,
Yeah,
minus 5,
yeah,
minus 32.
like this. Yeah. Did you get the same numbers?
No.
Did you get it? Okay.
I get the first one.
Okay, alright. Okay, so we have our numbers. So first step is write the introduction. Well, I won't, of course, do that now. Write your introduction about recursive sequence.
How many sentences? How long is it? Because we have limit.
Yeah, but don't worry if you go over the limit.
600.
Yeah, don't worry if you go over it. So, you know, if you gave me 250 words for an introduction, that's fine. Yeah. Okay. So the first thing we need to do is get the A and the B. So what you have here is you have the formula UN equals A UN minus 1 plus B UN minus 2. So you could say the third term is A times the second term plus B times the first term. Now if I look at my table, I know the first, second and third, they are minus 10, minus 3, minus 1. So I can say minus 10b minus 3a should equal minus 1. Or in other words, 3a plus 10b should equal 1. Now you can do the same thing again here with the sixth term. You could say U6 is equal to the fifth term and then b times the fourth term. So you get minus 33 equals a times minus 5. So that's minus 5a minus 1b. Or if you want, that's 5a plus b equals 33. So life is short. I won't show you how to solve this because you know how to solve this. I'll just give you the answer straight away. So let me see what I get. Now, here, when I solve this, I get a equals 7 and b equals minus 2. So that means I have my recursive formula, un equals a un minus 1 plus b times un minus 2. So this is the first part of the assignment, is getting to this formula for your sequence. Okay, so far, I'll zoom out a bit. Any questions about this part so far? Question? No? Is this okay? Can I continue? Yeah. So the next part is, now that you have the formula, yeah, question?
How
Yeah.
write one only?
Huh? By what?
Like one sequence only.
I don't understand.
Like just write like this only.
Oh yeah, well you got the A and the B, so now you can say this is the formula for my sequence. And then the next part is, we can use this formula to make more terms. So for example, let me just delete these ones here. Whoops, delete. Alright, so I'll type in my formula. Did you write down my formula? Because I need you to read it back to me. Yeah? So what's the formula equal to? It's 7 times the last one, which in this case will be minus 3, plus, what's the next one? Minus the term 2 steps ago, yeah? Which, what would it be here in this sequence? It would be minus 10.
But it's like minus 5 or something?
Was it minus 5? Was minus 2? Alright, so minus 2, not minus 1. So when I type this in, it should give me the right number for the third term. What was my third term? Did you write it down? No. I don't even remember. What was it? Minus 1. So this should be minus 1. And it is. And I think it was minus 1 again, wasn't it? So if I copy this down here, just copy and paste, I get minus 1 again. If I copy and paste again, I get minus 5. And minus 33. And this is as far as I originally went. But now that I have my formula, I can go further.
How many numbers?
Well, it depends on your sequence. So my sequence is getting pretty big. I think maybe I've gone too far. So for me, maybe I should stop at like 10. Maybe. It depends on how quickly your sequence grows. Okay? The next part is to make a graph. What type of graph would be suitable here?
Column?
Yeah, that's the one. So insert chart. And I think a suitable graph would be like this one here, the column graph.
Is it okay if, like, you can't see the values of the first terms because
Yeah,
it's quite small?
Yeah, I think it's okay, but maybe you want to cut some of the big terms out from the end. It's going to be different for each person.
Because, like, this one is okay. For the next graph, it will be. It
Yes.
will give you the idea. That
Yes, yes. Sequence UN, and the formula here is UN equals, what was my A? What did I say the A? 7, wasn't it?
Yeah.
U N minus 1 minus 2 U n minus 2. The x-axis is n, and the y-axis is un. Okay, I don't really need an x, just need the y. The graph should look something like this. Now, this graph is bad. I have too many terms. I should probably really stop at 12 because 13, 14 and 15 is so big, it's making the other ones impossible to see. So, listen, don't you do this. This is bad. I've gone too far, like normal. I've just gone too far. So I should cut out some of the numbers at the end because this is way too big. Okay? So for me, maybe I should have stopped at 10 or 11. Okay? Now you will lose marks if you don't do everything you need to do in your graph. What I mean is, does my graph have a title? Yes. Do I have a label on the x-axis? You can barely see it. Where is it? There it is there. Do I have a y-axis name? I do. Yeah. So sometimes students forget the basic things like having a title and then they lose marks. Don't do this, please. Make sure you have your title. Okay, can we continue? Silence means you're amazed by my graph, or you don't want me to continue, or you've stopped caring. Continue? Yes? Okay. Right, the next part. So what I say is, there is actually a way to get the formula without using a recursive formula. I actually say that you could try this as a formula for un. You could say un is some constant e power some constant n. Do you see what I mean? So what I'm saying is, I'm giving you what I think is a formula for un directly. So you just put in the n and you have the number. Now, if you look at my graph, that seems fair because what shape of a graph is this? It's kind of shooting down like this, isn't it? So what type of graph is that? That's like exponential where the A is negative and the B is positive. Do you remember these four graphs? Not even close, huh? Do you remember doing graphs of this form? Yes, and if the graph is kind of going like this, that's when the A is negative and the B is positive. So I'm thinking, oh, maybe I can try something like this, and I think maybe the C will be negative and the K will be positive. From looking at the shape. So this is the motivation for making this choice. Because the graph looks like this type of shape.
But like for me, it like goes up and down faster than it goes down.
Yeah, don't worry. We'll explain that in a moment, okay? But it's still going to be this for you. Because I also said it here as well. But there is a reason it goes up and then back down. We'll get to that in a minute. Okay, so what I do, before... Question? Yeah.
What should we talk about the graph?
Oh, well, we should talk about if it's divergent, if it's convergent, what shape it makes. So, for example, my graph has this kind of exponential shape going down, whereas Malik's graph, you said it increases before going down, wasn't it?
Yeah.
Yeah. That's what I mean. Comment on the shape of the graph.
For how long is it?
You know, 50 words at most, you know.
With the table or separately?
Oh, you can just put it in a paragraph. Do you mean...
For both of them, the table and the graph?
Yeah. Or you can put the comment together for both. You know, you can say, from the table and the graph we can see. You know. I want to leave it flexible enough for you, okay? If you want to do it this way, that's fine.
No, I need one.
Question? Yes?
For the graph, do we have to do bar charts or can we do like a normal x or y axis graph?
Technically a bar chart because x and y is only when the values could be anything, like x could be 1.5, but you see here with a sequence the n must be 1, 2 or 3, so then it's more suitable to do a bar graph where each bar is the n1, n2, n3. Okay, can we continue from here? Yes? So what would u n minus 1 equal? That would be c e k n minus 1. And what would u n minus 2 be? That would be c e k n minus 2. So you can take these three things and put them back in. So you would get c e k n equals 7 e k n minus 1 minus 2, oh sorry, let's have a c here, minus 2 c e k n minus 2. Now, something cancels here very nicely. What cancels? C cancels quite nicely. So out it goes. EKN equals EKN minus K minus 2 EKN minus 2K. Thank you. There should be a big fat 7 here. Okay. And you see I expanded in the powers as well. And what are you saying, Malik, to do next?
Divide all by EKN.
Yeah. Divide everything now by e power kn, e power kn, e power kn. So the powers subtract kn minus kn equals 7 e kn minus k minus kn minus 2 e kn minus 2k minus kn. So it means that cancels that, that cancels that, that cancels that. So I have e power 0 equals 7 e power minus k minus 2 e power 2k, minus 2k. So far so good, I guess. I mean, what do we do next? So far so good, but it's not exactly ready to find the k. What do you think?
Multiply by
e to the 2k. Multiply everything by e to the 2k. So here we have e to the 2k, e2k, e2k. So we get e0 plus 2k equals 7e2k minus k minus 2e2k minus 2k. So this would be e2k equals 7ek minus 2e0. But e0 is power 1. E0 is 1. So e2k equals 7ek minus 2. Starting to look familiar? It's a quadratic. E2k minus 7ek plus 2 equals 0. Ek squared minus 7ek plus 2 equals 0. Yes, now it's different for everybody. Some people can factorize, some people cannot. I cannot.
By the way, does it have solution?
Yeah. I really tried hard to make sure everybody's quadratic has 2 solutions. If it doesn't, please see me. But I mean, I'm 99% sure I made everybody's quadratic at this point have 2 solutions. Now some people's quadratic will have, you have what?
One of my solutions is 0.
Oh, that's fine, that's fine. If one of the solutions is 0, that's fine, yeah. And maybe somebody, I don't think anybody will have the same solution twice. One of the solutions could be 0, but you should have 2 different solutions. Now, the solution could be a nice number, or in my case, an ugly number. So if you want, you can use decimals, that's fine. So here, my first solution from using the formula is EK is 6.70156, or EK equals 0.29844. Okay? Now I don't want the K. What do I want? I do want the K. I don't want EK. So what should I do next? I should put a log here. So I get K equals log 6.70156. So that means K is 1.9023.
So how many decimal places do you want?
I think 5 is good. 4 at least. No, 3 is pushing it to the limit. 4 would make me happier. Well, you see, the other thing is it depends. Marcelo, it depends at the end. You have to make another table at the end, which should be the same as the table you got at the start. So if 3 places of decimal allows you to have 2 very similar tables, that's fine. It's just, I'm going to use 4 because my numbers are getting really big. That's why, yes?
I got whole numbers. Is this okay?
Yes, this is.
Because I will use it for the next
Yes.
step. I guess if I said K it's log 2.
Yes. Yes, that's fine. That's fine. That's fine.
Or
Yes.
do you want the whole number?
No. Log 2 is fine. If you want to, that's perfectly fine. No problem. Yep. And here I get K equals 0.29844 minus 1.20919. Hey, come on. So I got 2 answers for K, whereas, please, I got 2 answers for K, which is fine. It just means it's not this, but rather it's probably this. 2 different functions added together. Now, Malik, this is why your graph goes up and goes down, because at the beginning the positive one is bigger, so it's making the graph want to go up, and then later your negative one will be bigger, it's making the graph go down. So this is why you get this up-down pattern, because there's 2 competing functions here. Okay, so I know what my K is. So I have Y equals C1 E1, sorry, I wrote X, of course that's not X, it should be N. 1.90234N plus C2, and of course, why am I writing Y? It's not Y, it's, what is it? UN. E minus 1.20919N. Yep. So we're trying to get a different formula for the same sequence. What I'm missing now is the C1 and the C2. But I remember that, I know what the first term is. What's the first term? Oh. Let me get rid of this table. Was minus 10, was it? So if the first term is minus 10, it means this should be true. N is 1. N is 1.
You can also use like ln.
You can, that's what Malik was asking me. So you could keep logs in here if you prefer, yeah.
And as you said, E to the log...
They cancel, exactly.
Yeah.
So you can keep it very neat here if you want, yeah. You could have an E and a log and they both are gone and you have a very neat expression. That's fine. This would make me happier if you did it this way.
Yeah, I would love to have them.
Yep.
Whole numbers.
Whole numbers is good, yep. Okay, so 90234. So here I have minus 10 equals C1 6.7016 plus C2 0.29844. Let me write that again a bit neater. 6.7016 C1 plus 0.29844 C2 equals minus 10. Oh, so
Why
ugly.
minus 10?
Minus 10 was our first term. So what I'm doing is I'm using n equals 1 to make an equation.
Must be used the first term.
No. If you use any term, you'll get the same answer as me. Yeah. Just, 1 is small. So I like small numbers. So I'll use n as 1. So the next one I'll use, have a guess?
2.
Exactly. So I'll put in n as 2. What was my second term? I don't remember. Minus 3 or something?
3.
Was it? Ah, I can't move out of the way. Was minus 5? Oh no, hang on. Minus 3, yeah. So here I have, if I use this here, but now if I use n is 3, I'll get n is 2. I should have minus 3 equals C1 E 1.902342 plus C2 E power minus 1.20919. So let me clean that up. So I should get here 44.911 C1 plus 0.08907 C2 equals minus 3. Ugh, can't draw boxes today. You know what a box looks like. Right, so I'm in a very similar situation again. I have two equations with two unknowns. So what method should I use? Whatever I want. Elimination, Gaussian, substitution, anything except the graph. Okay? So I assume you know how to do that, but if you're having a little bit of trouble here because of the decimals, my advice would be here, you should divide everything by 6.7016, and here divide everything by 44.911. The reason for doing that is you'll make a C1 here and you'll make a C1 here, which you can easily cancel then. Okay, so imagine I did that, I would get so I get here C1 is a tiny number, minus 0.0003608, and my C2 is probably a big number, well, pretty big, minus 33.5. Does anyone have my values of k from earlier? Did anyone write the k values down?
1
minus
1.
Okay, no, just for a sec. Okay, so I have un equals minus 0.0003608 e. What was k1? 1.90334. And then my other one was a minus 1.20919, like this. Now, yes?
Can you scroll up?
Yes. How far? This far? I can't. Can you still see it? Is this okay? Yeah. So now you have a formula for un. You just put in the n and you get the term. So for example, if I put in n equals 1, what should this equal? If I make n equals 1, what should this equal? What should it equal? Oh no, come on, this isn't a trick. I'm not trying to trick you. If n is 1, what does that represent? What is n equals 1 here? What is n equals 1? What is u1?
First term.
Thank you, the first term. What is the first term?
Minus
Minus 10. So if I put in n equals 1, I hope I get minus 10. Let's check. Minus 0.000368 e power 1.90234 n, which is 1. Minus 33.5 e power minus 1.20919 n is 1. Minus 10.00012. Great. What happens if I put n equals 6? What should I get? What should I get if I put n as 6? The sixth term. What's the sixth term?
minus 5, minus 3.
It was minus 33, wasn't it? The sixth term? Yeah, wasn't it minus 33? Let me check. Minus 32.7. Close enough.
So do you have to put all the
Yeah, so now what you need to do is make the table again using this formula.
but this formula is different than the first
Well, because you have nice numbers in yours, and if you don't round off too early, the values could be the same. If people have nice numbers, the values will be the same, but it's fine.
I got only the first term change.
And how different are the other terms?
Completely different.
Then you've made a mistake, I'm afraid. They should be very similar.
Should be very similar.
Very similar. Like, for example, my sixth term should be minus 33, and I got minus 32.7. I would accept that. But if you got 5, then it's, way off. Has anybody made the table at this point? I mean, has anybody made it this far, getting this formula, yeah? And have you made a table from this formula?
Yeah.
And is the table the same or different? Very different?
Not very.
Then slightly different is okay. Yeah?
I got different, but it's repeating. It's like going something differently, going up and down.
But how different? How different? Like, give me an example.
For the first term is 4 and 4.
No, give me something like the sixth term.
I will give you my terms
Yeah.
here. 4, 7, 11, 13, minus 1, minus 83.
Okay, minus 83. Okay, so what's it on the other table?
7.6.
Oh, yeah, okay.
But the thing here is like it's repeating. It's
So-
0, 13.
So are you saying every second term is accurate and every second term is inaccurate? Like it's accurate, not accurate, accurate, not accurate? No? Show me what
Only
you got.
the
Up and down. I think 4, 13, minus 5, 0, yeah, from here you took me. Ah, okay, so something went wrong in your calculations for the C's and the K's. Now the 3 and 2 looks okay. Maybe the problem is just with the C1 and the C2. So what you could do is, yeah guys, actually see the other thing is, the advantage with having the Casio calculator is that you can check your solution on the Casio calculator. So for example, if you're wondering how I was able to get the C1 and the C2 so quickly, there's a mode here, mode 51. Mode 51 lets you solve a degree 2 system. Mode 51. So, Malik, do you have this type of calculator? So if you have this one, you can check your C1 and C2 and your A and your B, because mode 51 can solve a simultaneous, a degree 2 equation. Yeah, so you got mode 51? Yeah. Now, so it'd be like ABC, ABC. Continue?
The C will be negative 10 or 10.
Yeah, no, be negative, oh my goodness, actually, what is it? It'd be negative 10, yeah. Yeah. Yeah, that's fine, yeah. No, it's close enough, like, that's only 1% different. 1%. Okay.
Are you sure it's negative 10?
I am 100% sure you type it in as minus 10. So you type this in as 6.7, 0.2 and minus 10.
Because if you use the third one, it's not.
No, yeah, but the third one you see, but in the first one the C is on the right of the equals, whereas here it's on the left. Yeah. I know, it's a bit odd, but that's the way they do it. Okay, continue. Yeah. Okay, so I have my equation written like this. So the next thing I want to do is make the table. So let me just... Okay, so what I'm going to do here is write down the n. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And here I'll put in my new formula. Did somebody write this down? Because I need you to read it back to me. Yeah, okay, so equals, what's the start? Minus 0.0003608 times. Now the way to make E, I think, is X. Yeah, X means E. K, what was the K? What's the next part? My formula, did you write it down? This isn't cinema, you know, you need to be doing stuff too, okay? There's no popcorn around here. 1.90234 times n. And here is n. Let me click n. Minus, and the next one is, what was it? 33.5 exp, and then minus 1.20919 times n. So it's pretty close, isn't it? Minus 10, minus 10. So if I copy this down, it's not too bad actually. I know it looks like a big difference here, but as a percentage, it's less than 1%. Maybe it's, yeah, it's less than 1%, because here you have 8,9 and here you have 8,9. It's 891 and here is 899, so that's less than 1% error. And it'd be more accurate if I took more decimal places. Okay, is that okay? So you should get something like this here. If it's exactly the same, that's even better. Okay. The next step. This looks like what type of sequence from an AP and GP. It kind of looks like what type of formula. It looks a little bit like a GP formula. Do you remember what GP is? A or n minus 1. Now it's not exactly GP, is it? No, it's nearly GP. I mean, we can kind of see what the A is. We can kind of see what the OR is, but we don't have any N like this. It's a little bit messy, so we'll have to clean it up a bit. So what we could do is write it like this. E power 1.90234 power n minus 33.5 e power minus 1.20919 power n. So it's looking a bit more like a GP formula where you have a or n minus 1. So what am I missing in this to make it more like a GP? What am I missing? The minus 1 up the top. That's all I'm missing. So you could put in a minus 1. Like for example, if I just
add 1 in the UN and minus here.
That's it, add 1 and minus 1. So what you could do is, if I just go back a step before doing this. So you have an idea there, Malik, which is fine. I think it'll work. But it's not quite minus 1. You said minus 1 and add 1. It's almost that. It's not quite that.
But to UN?
Yeah.
In the first.
Oh, here?
Yeah.
I know, I was thinking here. So what I could do is I can put in a minus 1 point. Now look, I'm just going to save space because I can't squeeze it in here. So I'm just going to do it for the first one. But you can do the same trick for the second one, okay? I'm just saving space here. So I can do minus 1.90234 plus 1.90234. And then there's the other piece as well. Now you can see what's going to happen. This is 1.90234n minus 1.90234 all over no, not all over, times e power 1.90234 plus the other piece. Why did I have to multiply here? Well, when you multiply, what do you do to the powers? You add them. So this here is the same as this. I'm splitting this into 2. Now the reason for doing that, if you look here, what can I take out? Yeah, I can take out minus 0.003608 e power 1.90234 bracket n minus 1 times e power 1.90234 plus the other fella. And then I can put these together. Minus 0.003608 e power 1.90234 bracket e power 1.90234 bracket and here is n minus 1. So now you can see, this is like the A, this must be the OR, and this is the n minus 1. Now you have to do the same for the other one, but that's okay. It's the same trick. You would get minus 33.5 e power minus 1.20919 e power 1 minus 1.20919 and then run out of space n minus 1. Problem? Made a mistake?
So,
Yeah.
Can you say again what's the A and B, what's the A and R?
Yeah, I wouldn't have a second, Jack. Power minus 1 power minus 1. I know it's getting a bit tricky here, but we are getting near the end of the assignment. So, you know from GP, the formula for a GP is A or n minus 1. So if you look here, that's what you have. You have here A or n minus 1, A or n minus 1. But you have two GPs. So at the end, I ask you to calculate S10. So what I recommend you do is you split this into two GPs. Here, S10, and here, S10. Do you remember the formula for S? It's A 1 minus Rn over 1 minus R. And here it's the same, A 1 minus Rn over 1 minus R. But what's the A here? Well, it's that big thing there. What's the R? That thing there. What's the N? 10. Here, there's the A. There's the R. And the N is 10. So I'm going to write down what the A equals, what the R equals, what the A equals, what the R equals. So A is minus 0.003608 times e to the power of 1.90234. So my A is minus 0.02418 and my R is e power 1.90234. 6.702. And here my A is minus 33.5, e power minus 1.20919. So my A is minus 10. And then my R is e power minus 1.20919. My R is 0.2984. So if I use my formula here, S10 would equal, and S10 would equal. Yeah, mistake?
Is it minus 0.000306?
Oh, I left out a 0, didn't I? Well, that's easily fixed. I just need to stick an extra 0 here. Are you saying I missed a 0 here?
No.
Well, here, I carried it down. It should be 4 zeros, isn't it? So I just missed a 0 here. Okay, let's check S10. A minus 0.002418 times 1 minus R power 10 over 1 minus R. So here I get minus 77,531. And here, minus 10 brackets 1 minus R power 10 over 1 minus R minus 14.25. So when I add these two together, my total for the first 10 terms, both halves, is about minus 77545. Now there is a way I can check that this is right. Excel, let's add up the first 10 and see if we get minus 77,000. So here is the sum of the first 10. Now I'm not very accurate because of my rounding off. I got minus 77,500 and it should be more like minus 78,000. I know that seems like a big difference, but it's actually quite good considering my rounding off because my numbers are so big. So this is what I want to see. Some of you will be much more accurate than this, which is good. The reason this is useful is because imagine you didn't have Excel and I asked you to calculate S1000. If you did this whole process, at the very end, what is the only thing you would need to change? The 10 to 1,000. Okay? So what this assignment is trying to get you to see is you can go from a recursive sequence to a situation where it's very easy to add up all the terms in the recursive sequence. Like, I mean, if I said do this manually, It'll take you a long time to do if you have to go to n is 1000. But by doing this whole process, I know it seems long, but it's much quicker than doing the 1000 terms added together by yourself. Okay. How far did people get in this assignment now? So, did anybody get this far? And how close was your answer when you added up the first 10 using the GP formula compared to the Excel? Ah, okay. What type of answer did you get for S10? Was it a big number like this? Yeah. So you've just seen me do everything here. I'm going to upload this to my YouTube channel. Yep. After 5. So the link I have on Moodle is from last year, and there's a bit of a problem between the sound and the video. They don't match up. So if you want to watch this lesson, you need to go to the channel. Okay? I'll call the lesson Maths Coursework 1 or Maths CW1. Yeah, I'll just call it Maths CW1. It'll probably be at the top of the video list, most recent upload.
And how about the conclusion? What we can write?
Oh, the conclusion, well, you know, tell me everything you've learned, maths is important, useful, blah, blah, blah. You know, make me feel good. Yeah? No. You could just say, oh, we use the elimination method to solve this degree 2 system. Or you could even say, by multiplying by blah and blah, we can use elimination and quickly get the following answer. I don't need every mathematical step explained, but I certainly need you to say something like, we are using the elimination method. Yes? I make no promises, but you can tell them to email me, okay?
Can we get the full mark?
Huh?
Can we get the full mark?
Full mark? 100%. It is possible. I think the highest I've given so far has been 97, 96. 100. That's a special type of work to get 100. But you can definitely, you know, a lot of hard work can get you in the 90s. But that's a lot of hard work.
If you have all the calculations right.
All the calculations are perfect. If your English is perfect, you can get 100.
We have problem with English.
Yeah, this is the thing. But the calculations should get you the A star if you do the calculations and the graphs correctly. I mean, the English is worth maybe, what you write is worth maybe 20%, and the calculations and the graphs, that's 80%. So you can, bad English won't stop you getting an A star. It'll stop you getting 100. Okay.